Hello children, how are you all? Good morning everyone. In the previous class we have seen about friction, the types of frictions and the applications of Newton's law. Okay. Today we are going to see about angle of repose and the applications, okay, and what is friction, okay, methods to reduce the friction, dynamics of circular motion, what is centripetal force, okay, what is banking of tracks, what is centrifugal force and the effects of centrifugal force, okay, like this we are going to see in today's class. Okay, physics is a very interesting subject. Okay, in each and every day of life, each and everything which we are experiencing in our life is given in this subject. Okay, is given in this subject. So study physics, okay, very interesting manner, okay, very interesting manner. Let's go into the lesson. Now first of all, what is angle of repose? What is angle of repose? Okay, it is the minimum angle, okay, it is the minimum angle that an inclined plane makes with the horizontal. Inclined plane makes with the horizontal when the body placed on it, okay, when the body placed on it just begins to slide down. Have you noticed in aeroplanes there is a horizontal body and an inclined stairs? You have to go through the upstairs in an inclined path, go through the upstairs in the inclined path, okay, that is the angle of repose. Angle of repose is the minimum angle. It is the minimum angle that an inclined plane makes with the horizontal when a body placed on it just begins to slide down. Let any inclined plane inclined with the angle with horizontal and the body which mass is m just begins to slide down. Have you seen the seesaw? Have you seen seesaw? The children will play, no? It is fixed on a horizontal surface, but it is in an inclined, okay, looking like a triangle, okay, it is in an inclined form. So for that purpose, okay, for that purpose, to avoid the skidding or falling down, this principle is followed. So this angle theta is the theta of friction. So finally the theta is equal to tan inverse of -1, tan inverse of -1. So the angle of repose is same as the angle of friction. The angle of repose is same as the angle of friction. Do you understood? So consider an inclined plane. Consider an inclined plane on which an object is placed. Consider an inclined plane on which an object is placed. Let the angle which this plane makes with the horizontal be theta. So for small angles of theta, the object may not slide down. So as theta is increased for a particular value of theta, the object begins to slide down. So this value is called angle of repose. So this u is the coefficient of friction and n is the normal reaction. So n equal to mg cos theta. Okay, the theta equal to tan inverse of -1. That is the angle of repose. See the applications here. It is in a angle of repose. A horizontal surface la kuvichu potrukangla. Okay, that is the angle of repose example. Okay. Now what is rolling friction? What is rolling friction? Okay, the invention of the wheel, okay, invention of the wheel plays a crucial role in human civilization in the previous days. Okay, the invention of wheel plays a crucial role. So one of the most important applications is suitcase with rolling coaster. Have you seen the suitcase with rolling coasters? Yes. So, one of the most important applications is suitcase with rolling on coasters. So, rolling wheels makes it easier than carrying luggage, isn't it? So, carrying the luggage is enough hard, isn't it? So, if there are rolling wheels, so it is easier for us to carry the luggage. So, when an object moves on a surface, essentially it is sliding on it. When an object moves on a surface, essentially it is sliding on it, but wheels move on the surface through rolling motion. So, in rolling motion, when a wheel moves on a surface, the point of contact with surface is always at rest. Since the point of contact is at rest, there is no relative motion between the wheel and the surface. So, the frictional force is very less. At the same time, if an object moves without a wheel, if an object is moving without a wheel, there is a relative motion between the object and the surface. As a result, the frictional force is larger. This makes it is difficult to move the object. So, ideally, in a pure rolling, the motion of the point of contact with the surface should be at rest, but in practice it is not so. So, due to the elastic nature of the surface at the point of contact, there will be some deformation on the object at this point on the wheel. So, due to this deformation, there is a minimal friction between the wheel and the surface. The friction that occurs when an object rolls across a surface. So, it is easier to overcome than sliding friction. Example, anything with wheels, that skateboards, cars, suitcase with wheels. These are the example for rolling friction. Now, what are the methods of reducing friction? So, what we can do, we can polish, we can lubricate. Use of ball bearing or roller bearing. Streamlining, use of correct combination of surface in contact. Let me tell one by one. So, frictional force has both positive and negative effects. So, in some cases, it is absolutely necessary. Walking is possible because of frictional force. We are walking in the road, isn't it? It is due to frictional force. Vehicles such as bicycle, cars can move because of the frictional force between the tire and the road. There is a friction. So, it can move. So, in the braking system, kinetic friction plays a major role. You understood? In the braking system, kinetic friction plays a major role. So, as we have already seen, the frictional force comes into effect whenever there is relative motion between two surfaces. So, in big machines used in industries, relative motion between different parts of the machine produce unwanted heat, which reduces its efficiency. To reduce this kinetic friction, lubricants can be used. Ball bearings can be used. So, if ball bearings are fixed between two surfaces during the relative motion, only the rolling friction come to effect. Do you understood? First of all, polishing the surface. We have to polish the surface. It reduces the irregularities and it reduces the friction. Polishing the surfaces reduces the friction. Next, lubrication with certain oil. It also reduces the friction. Further, use of ball bearing, roller bearing help to convert sliding friction into a milder form. So, rolling friction is lesser than sliding friction. Next is streamlining. Fast car, boat, plane, etc. have a streamlined body. What is streamlined body? See the picture. Both the sides are looking like a bird's body. So, the boat, aeroplanes, they have a streamlined body. This is to allow air to easily flow by without offering much resistance. Use of correct combination of surfaces in contact. So, use of alloys on moving and sliding parts reduces friction because alloys have a low coefficient of friction. Now, what are the frictional force in the motion of a bicycle? So, when you walk on a tiled floor, when water is spilled, what happens? You slip, isn't it? That is the frictional force. Right. So, when a bicycle moves in a forward direction, what is the direction of frictional force in the rear and front wheel? So when we pedal a bicycle, okay, when we are pedaling a bicycle, we try to push the surface backward and the velocity of point of contact in rear wheel is backwards. So the frictional force pushes the rear wheel to move forward. But as the front wheel is connected with a rigid support to the back wheel, the forward motion of back wheel pushes the front wheel in the forward direction. So the frictional forces act backward. Remember, both frictional forces correspond to only static friction and not kinetic friction. So if the wheel slips, then kinetic friction becomes into effect. So in addition to static friction, the rolling friction also acts on both wheels in the backward direction. Okay. Now dynamics of circular motion. Dynamics of circular motion. Okay, in the previous sections we have studied how to analyze the linear motion using Newton's law. Linear motion pati paathom. Now we are going to see about the circular motion. So Newton's law to circular motion, since circular motion is one of the very common types of motion, it is one of the very common types of motion that we come across in our everyday life. So a particle can be in linear motion with or without any external force, but when circular motion occurs, there must necessarily be some force acting on the object. So there is no Newton's first law for circular motion. So there is no Newton's first law for circular motion. So in other words, without a force, circular motion cannot occur in nature. Without a force, circular motion cannot occur in nature. So a force can change the velocity of particle in three different ways. First of all, the magnitude of velocity can be changed without changing the direction of the velocity. So in this case, the particle will move in the same direction but with acceleration. Examples, okay, I will tell you the examples. Particle falling down vertically, bike moving in a straight road with acceleration. These are the examples, okay. So next, the direction of motion alone, okay, direction of motion alone can be changed without changing the magnitude, that is speed. So if this happens continuously, then we call it as uniform circular motion. So both the direction and magnitude of velocity can be changed. If this happens, non-circular motion occurs. For example, oscillation of spring, okay, elliptical motion of planets, simple pendulum, okay, motion of planets around the sun. These all are the circular motion. Now, what is centripetal force? Centripetal force, okay. So, if a particle is in uniform circular motion, a particle is in uniform circular motion, there must be centripetal acceleration, okay. ஒரு ஆப்ஜெக்ட் வந்து சர்க்குலர் மோஷனில் இருக்கும்போது அங்கே கண்டிப்பாக என்ன இருக்கும், ஒரு ஆக்சலரேஷன் இருக்கும். அது பேர் சென்ட்ரிபீட்டல் ஆக்சலரேஷன். இட் இஸ் டுவர்ட்ஸ் த சென்டர் ஆஃப் த சர்க்கிள். ஸோ இஃப் தேர் இஸ் ஆக்சலரேஷன், தென் தேர் மஸ்ட் பி சம் ஃபோர்ஸ் ஆக்டிங் ஆன் இட். ஆக்சலரேஷன் இருந்துச்சுனாலே ஃபோர்ஸ் இருக்குமா, ஃபோர்ஸ் ஈக்குவல் டு ma. So if there is acceleration, then there must be some force acting on it with respect to an inertial frame. This force is called centripetal force. This force is called centripetal force. Okay, as we have seen in the previous chapter, centripetal acceleration of the particle A equal to v square by r. V square by r, that is towards the center. So in case of whirling motion of a stone tied, okay, tied in a string, the centripetal force of the particle is provided by the tension force, and the motion of satellites around the earth, okay, and the whirling motion of objects, okay, in roller coaster, the round motion, okay, when a car is moving in a circular track, centripetal force is given by the frictional force between the road and the tire, okay, when the car is moving in a circular track. Okay, and when the planets, okay, orbit around the sun, they experience centripetal force towards the center of the sun. So here gravitational force of the sun acts as a centripetal force. That force is the centripetal force. When planet rounds, orbit around the sun, planets orbit around the sun, then they experience a centripetal force towards the center of the sun. So here gravitational force of the sun acts as a centripetal force on the planets. Okay, this is the gravitational force of sun on planet. We understood. Some example is given. A ball of mass is attached to a string. See here, ball of mass is attached to a string. Its weight is supported by the frictionless table. The tension in the string causes the ball to move. Okay. See here Newton's first law, F equal to m into a. For centripetal force, that is Fc. Fc equal to m into AC. What is AC? Centripetal acceleration. So in the previous class we have seen acceleration, centripetal acceleration is equal to v square by r. Okay, v square by r. So F equal to m into v square by r. So centripetal force is equal to mv square by r. You should remember the formula for centripetal force equal to mv square by r. mv square by r. Now, vehicle on a levelled and circular road. Vehicle on a levelled and a circular road. So, when a vehicle travels in a curved path, okay. Second picture, no. When vehicle is traveling a curved path, there must be a centripetal force. There must be a centripetal force acting on it. So, this centripetal force is provided by the frictional force. The centripetal force is provided by the frictional force between the tire and the road. So, tire ku road ku nadusla irukra force da enadhu frictional force. Okay. So, consider a vehicle of mass m on the road at a speed v in a circular track of radius r. So, there are three forces acting on the vehicle. Three forces. One is the gravitational force, that is mg, and one is the normal force, that is acting upwards. Okay, normal force acting upwards, and third one is the frictional force between the road and the tire. Okay, three forces acting on the vehicle in a circular road. Suppose the road is horizontal, then the normal force and the gravitational force are exactly equal and opposite. What happens? The centripetal force is provided by the force of static friction Fs between the tire and surface of the road, which acts towards the center of circular tracks. Okay. Now, what is banking of tracks? Banking of tracks. Okay. In a levelled circular road, okay, circular road, skidding mainly depends upon the coefficient of static friction, that is mu. So, the coefficient of static friction depends upon the nature of the surface, which has a maximum limiting value. So, to avoiding this problem, okay, to avoid this problem, usually outer edge of the road, okay, outer edge of the road is slightly raised. Inner edge விட outer edge வந்து கொஞ்சம் உயர்த்திருப்பாங்க. This is called the banking of road. Skidding தடுக்கணும் அதுக்காக inner edge விட outer edge உயர்த்தி கட்டியிருப்பாங்க. That is the banking. So, certain angle of inclination is there. Okay. See the picture? The angle of inclination, that is called the banking angle. If the surface of the road make angle theta with horizontal surface, then the normal force makes the same angle theta with the vertical. So, when the car takes a turn, there are two forces acting on the car. First one, gravitational force mg and the normal force n. So, we can resolve the normal force into two components, n cos theta, n sin theta. We can resolve the normal force into two components, n cos theta and n sin theta. The component n cos theta balances the downward gravitational force mg, and component n sin theta will provide the necessary centripetal acceleration by using the Newton's second law. Okay, the banking angle theta and radius of curvature of the road determines the safe speed of the car at the turning. So, if the speed of the car exceeds this safe speed, then it starts to skid outward. Understood? But frictional force come in contact with the effect and provides additional centripetal force to prevent the skidding. At the same time, if the speed of the car is little lesser than safe speed, it starts to skid inward. Starts to skid inward. You understood? This is the banking of tracks. Now, what is centrifugal force? Centrifugal force. So, circular motion can be analyzed from two different frames of reference. Okay. One is the inertial frame, whether it is at rest or uniform motion where Newton's law are obeyed. The other is the rotating frame. Inertial frame according to Newton's law, and rotating frame which is a non-inertial frame of reference as it is accelerating. So, when we examine the circular motion, okay, these frame of reference, the situations are entirely different. To use the Newton's first and second law in the rotational frame of reference, we need to include a pseudo force. Okay, that pseudo force is called the centrifugal force. Okay, now the red object will make in turn. Okay, the red object Now what happens, the red object will make the turn only if there is enough, the red object will make the only turn if there is enough friction on it, otherwise it goes straight. So it is not a real force, it is a pseudo force, it is a pseudo force. It is not a real force. So an object will not move in a circle until something makes it, This is the centrifugal force. Some examples of centrifugal forces, okay. A person standing on a rotating, see here, a person standing on a rotating platform, okay, feels an outward centrifugal force and is likely to be pushed away from the platform. So many times a frictional force between the platform and the person is not sufficient to overcome the outward push. So to avoid this, usually the outer edge of the platform is little inclined upwards, which exerts a normal force on the person, which prevents the person from falling, So they understood. This is the centrifugal force. So although centrifugal force is a pseudo force, its effects are real. So when a car takes a turn in a curved road, person inside the car feels an outward force which pushes the person away. This outward force is also called centrifugal force. If there is sufficient friction between the person and the seat, it will prevent the person from moving outwards. So when a car moving in a straight line suddenly takes a turn, the objects not fixed to the car try to continue in linear motion due to their inertia of direction. So this centrifugal force is called zero force. It is not a real force, okay. It is an unreal force, okay. So it is dangerous to stand near the open door or steps while traveling in a bus. It is dangerous to stand near the doors. When the bus takes a sudden turn in a curved road, due to centrifugal force, the person will push away from the bus. Okay, have you seen some person standing on the bus that steps? They are pushed away, no? That is due to centrifugal force. Even though centrifugal force is a pseudo force, its effects are real. It is a pseudo force, it is an unreal force, but the effect of centrifugal forces are very true one. Very real one, okay. Now what are the salient features of centripetal and centrifugal force, okay. First of all, centripetal is a real force and a centrifugal one the pseudo force, okay. The centripetal force is exerted on the body by the external agencies like gravitational force, tension in the string, normal force, okay. This is a real force. It is exerted on the body by the external agencies like gravitational force, tension in the string, normal force. What is centrifugal force? It is a pseudo force or fictitious force which cannot arise from gravitational force, tension force and normal force. Okay, and the centripetal force acts both in inertial and non-inertial frame, but centrifugal only in rotating frame. Okay, and the centripetal force acts towards the axis of rotation, that is mv square by r, but centrifugal acts outwards from the axis of rotation, outwards from the center of circular motion, that is mv square by r. And real force and real effect, pseudo force but real effect, okay. This is a real force and real effect, but centrifugal is a pseudo force but the effect is very real. Now the origin of centripetal force is interaction between two objects. Origin of centripetal force is interaction between two objects, but origin of centrifugal force is inertia. It does not arise from interaction. So if an inertial frame, the object's inertial motion appears as centrifugal force in the rotating frame. So in inertial frames, the centripetal force has been included when free body diagrams are drawn. So in rotating frames, both centripetal and centrifugal force has to be included when free body diagrams are drawn. Okay, these are the salient features of centripetal and centrifugal forces. This lesson is completed, okay. Go through it, okay. You have to write 10 one words, okay. 10 one words from application of Newton's law to page number 156. Okay, and go through the banking of tracks. Okay, banking of tracks, write it with the example, and centrifugal force with examples. What is centrifugal force, and write its example, and give the difference between centripetal and centrifugal forces. Okay, first of all 10 one words in homework, and rest 3 questions you write it as assignment. Okay children, that's all about today's class. Have a nice day. Stay home, stay safe. Thank you.